Okay, so I'm going to start off with this session. Stefan and myself, we're going to be talking about the issues of maintaining an Android release and how you interact your changes with the upstream aosp. So it's called Forking Android Considered Harmful, and as you can guess, the basic idea behind this is that we should try to avoid forking wherever possible. So the agenda then, Stefan is going to talk a little bit about the different ways that you can cope with a changing upstream, a changing aosp, and how you can avoid, or how you typically interact with that, and different ways of interacting with that. And then I'm going to come in and talk about why forking is a bad idea, and some ideas I'd like to discuss both in the meeting, both in this session and also offline, about what we can do about this. So, quick intro to myself. I think I'm reasonably well known. I've been doing this stuff for quite a long time. Main topics of interest. The point where software meets hardware. I've always been interested in the interface with devices, and I like to see actual hardware if possible. I have experience with Linux kernel, Yocto, and of course Android. I'm very interested in open source, and I'm very interested in the idea of communities. So that's me. If I hand over to Stefan.
Yeah, hi, I'm Stefan Lengfeld. I'm living in Germany. I'm working for Innovex. We are doing projects and consultancy, and I'm doing this embedded stuff, Linux embedded and Android embedded stuff since 10 years now. And yeah, main interests, embedded systems, Linux kernel development, build system, graphics stack, and performance analysis. And that's for myself, and the short introduction to the problem is again you.
Sorry, what?
Next slide is the slide.
Okay, yes, okay. So, the aosp developers dilemma. So the first point is the basic one. So in order to make a product out of aosp, you basically need to take a copy of aosp and then modify it in some way. So why do we need to do this? So typically you're adding in board support for whichever hardware platform you're using. Often you need to put in some custom HAL support, where you need to add in services, libraries, apps, and we may also want to change the upstream aosp code. We may want to change the way the framework works in some ways, because we need some different launcher behaviors. We will of course need to add in some SE policy and all kinds of stuff. So in order to do anything with aosp, apart from just build an emulator, you need to hack it around a bit. So how do you handle that?
And with that, we go into the section and how we are handling with that. They are typically, so we have to look at two different things. So one thing is that we at one point often have to fork something, or at least to patch some existing code. So patching framework code, for example, to fix a bug, or backport a patch for a fix, or adding new features in framework. But of course, this should not be done too much, because then porting is harder to new versions. So one thing we always do is fork or patch existing code from the aosp source tree or from the vendor tree you get from your SoC vendor. And the better thing is the additions. So a lot of things we add to the aosp tree, for example, HAL implementations, kernel drivers, additional apps, and other things. And both forking and addition, or patching and adding code, are two different tasks that we need to do as aosp developers, and in the options I will now present, also done differently. So we will go through the options that I've seen in the wild. Yeah, one question? Okay.
No speakers.
No speakers. This mic is only for the... So I have to speak louder. You're saying I should have spoken louder. Okay. Okay, I try to speak louder. So now we look at the 4 different methods I have seen in the AOSP, in the community or in projects, how we deal with that. So we look at the good, the bad, and the ugly methods. We use at the copy script option I have seen, which we're looking at using patches. We are looking at the local manifest feature from the repo tool, and we are looking at the way with copying and extending the upstream repo manifest, XML manifest. That are the 4 options we are now going through. So using a copy script. So we have the upstream, for example, the upstream ASP source tree from Google or from a BSP vendor, and you are the downstream. You are the downstream project. And with this option, what you are doing is you have a kind of in the bad case, you have a zip archive with code, or a customer has a zip archive with code, or you have a Git repository. And in this Git repository, you have files from the AOSP copied and modified. This is maintained by you. This Git repository is maintained by you. And then you write a README file, or you have a README file where you specify the upstream manifest version from Google or from your BSP vendor and the version. So someone who's working on the code then knows on which version you have based on the copied files and modified files. And then to be very convenient, you have a copy script. So you place also a script into the Git repository to then copy the patched files over to the actual ASP source tree where you then actually build. And how does a checkout look like? So you first do your repo init from the upstream XML manifest from Google, for example. Then you do a repo sync to download all the code. Then you git clone the downstream repository, so your code or the code of your customer or your downstream project. And then you execute this copy script. And with this way, then you have a patched AOSP source tree for your device or for your customer. And just I will not go much into the pro of cons of all these options, but I personally don't like this option. But I've seen it. For example, I've seen it in one upstream Git repository here, and I've seen it by customers. The problem is it's very hard to sync the files, the modified files in the AOSP source tree and the modified files in the downstream Git repository. It's very hard to track the changes. But I've seen it, and in simple cases, it works. What also I have seen in the wild is patches on top. I call it patches on top. How does a downstream project does it? It maintains a Git repository with patches, so not modified files, but patches, Git patches in there with descriptions, 10 patches, 100 patches. Then it also writes a README file to specify the upstream manifest and upstream version from Google or the BSP vendor. And also it has a convenience script to apply the patches then on the AOSP source tree. How does the checkout look like? Again, repo init from the upstream XML manifest, repo sync, you git clone the downstream project, you change directory in the downstream project, and then you execute the convenience script to apply all the patches. And then the patches are applied to your AOSP source tree, and then you can build and have your device enabled. And I've also seen some example of that in the Readout project, in the PinePhone project, and also Chris has a small project which also uses patches. So before we go to the third option, we look at repo manifest trick that you may know or may not know. It's the remove project trick. This is a repo manifest, XML manifest for a small project. You see these lines are adding Git repositories. So here we are talking about the addition. But below here, we see the remove project line. That is about forking. So how we can remove a repository from the upstream and replace it with our own fork. And this works with the remove project XML tag. You write down the name or the path of the repository, then it's removed. And then you since always only adds then your fork of it. You see that it's a fork because the remote is pointing to cool project. It's not pointing to the upstream anymore. And cool project is our host on GitHub. So with this, you can do the option 3. It's the local manifest. The local manifest is a feature by the repo tool. How does a downstream project use it? It maintains a Git repository with the local manifest XML. So, for example, this, some Git repositories added, some removed. This XML manifest is in this Git repository. Again, a README file to specify the versions, because the developer needs to know that. And then it also adds and forks some repositories of the aosp and places it on GitHub or somewhere. How does the checkout look like? It's now a bit shorter. Repo init from the upstream. Then we do git clone from the downstream project. And the important point is that we clone into the path.repo/local manifests. This is the repo local manifest feature. If XML files are in this folder, then it's picked up by repo, and then we do a repo sync, and the whole source tree from the upstream is sourced, and now also from the downstream is sourced. And here also some examples I've seen from one Raspberry Pi Android fork, and also here one from Snap Automotive. Now we go to the fourth option, but before we do the fourth option, another repo trick you might know of, it's the include. It's a small trick to make it more easy to maintain a copied or maintain your manifest. The include trick you see here is that if you have an XML manifest, you can specify the include tag, and with the include tag, another text file is included in this manifest. For example, here I copied the upstream manifest from Google, versions 13, and then my own additions, my own forks, new projects I added in another XML file. And with this, you can easily maintain a downstream fork. And And with this, we come to the fourth option, is the option copy and extending the upstream manifest. So now, you as a downstream project, you maintain a own manifest repository. You are not referring to a manifest repository from Google or for the BSP vendor. In that, you copy and include the upstream manifest from Google, and you also again add forks. You add and fork some repositories. How to check out? It's now very easy. Repo init from your downstream manifest repository, repo sync, and that's it. And you have cloned the source code. And examples, Baylibre does it, Project Celadon does it, and I cannot spell it, Calyx OS does it too. And that is the fourth options how you maintain your downstream fork of Android in the wild. And with that, I hand over to Chris to talk about why forking is bad, how to improve it.
Okay, so all of the examples we've seen really are in some way or other forking the upstream project. So, yeah, why is this a bad thing? So you may say, well, it's open source, we can do whatever we like with it, we can hack this around, whatever. However, forking any project is always a bad idea. It has a maintenance burden is the main problem. So once you've made the fork, you are now responsible for the for that code, for applying security fixes, bug fixes, whatever else. So you've taken on the responsibility for maintaining this code. And all you can do, you can, instead of backporting stuff into your fork, you can continually rebase your fork on the upstream version. But that also has some overhead, because when you do the rebase, you're bound to have some conflicts, and you have to resolve them and so on. Next point is something slightly more subtle, I think. When you make a fork and you start making changes to the code base, those changes tend not to be well separated. So developers often don't differentiate too much why they're making the changes, and there'll be changes to Git commits, but they don't necessarily relate to each other. So you end up with a bit of a mishmash of stuff. So here's our ESP, here's our fork, we change some stuff. You can look in the Git logs to find out exactly what we changed, but it's not really that obvious. As a result of all of this, we typically end up, when you're creating your own Android device, with a barrier which prevents you migrating to a new version. So it's quite common to find Android devices running old versions of Android, for example, Android 9, and running old versions of kernels, and yeah, it's kind of a nightmare. So to summarize, forking equals technical debt. We would like not to fork if we can avoid it. So how do you do this? Fundamental rule then is don't change aosp codebase, including do not change the manifest. What can you do? Well, you can add stuff. So you can add stuff into the local manifest, and this is the big thing here really, is to enhance patching. So instead of changing the code in situ, create a series of patches and apply those patches at build time. Additional benefit, if you do this in a clever kind of way, you can organize these patches into groups, which I'm going to call layers, which can be applied independently of each other, and you have a much more modular system. My inspiration for this really came from a number of places. I'm going to document two here. I'm going to mention first of all GlowDroid. So GlowDroid, as we mentioned, is an aosp distro for various boards, including Raspberry Pis. And it's interesting, if you look at GlowDroid 2.0, they changed the way that they are interacting with the upstream aosp, and they're using what they call a mono-repository approach, which is more or less what I just said. This is a little small, and I don't expect you to read all of it all in one go. The key thing is no more forking. Okay? So their idea is what I just said on a couple of slides back. Instead, we will take aosp, we'll create a set of patches, and then we have some build time tools which will apply those patches to the aosp. This makes it much more easy to maintain those patches. Also, notice this comment here. It says decouple devices or device groups from each other. In other words, we group those patches together into different functional areas. One for the changes to the aosp code base. Some are device specific. So that's my first inspiration. My second source of inspiration is from Yocto project. I don't know, how many people here are familiar with Yocto? Okay, about half. Good, right. So, Yocto is better than Android, yes? I'm going to take that. I think that was a yes. I definitely heard a yes there. Okay, so Yocto essentially does the same thing as the aosp build system, except it does it better, in my opinion. Just mapping a few concepts then, for those of you who are not familiar with it. Mapping Yocto concepts onto aosp concepts. So in Yocto we have a thing called bitbake, which does the same job as Soong. In Yocto we have recipes, which are BB files, bitbake files. They are more or less exactly the same in concept as Android BP files and make files. And I'm not going to go into this in much more detail, but Yocto also has classes. Bitbake is written in Python. These the classes are basically bits of Python code. That's where the real logic is implemented. In the aosp, the main build logic is implemented in the build directories, in build make, and also in build Soong. So we have this metadata, which are recipes, classes, and config files. And the key concept I want to borrow from Yocto here is the idea of a layer. So we have, they call them meta layers. So a meta layer is just a collection of metadata, recipes, classes, and so on. And the key thing here is there are several different types of layer. So we have BSP layers. For example, Raspberry Pi would be a good example. We have distros. Distros is a slightly complicated thing, which I don't want to go into now. But for example, AGL, the automotive grade Linux, is a distro. So if you want to build an AGL version of Yocto, you just include that layer. And it has what they call software. So these are typically libraries. So Meta Qt would be a good example. Qt is the graphics library. And then when you're building a product, you just patch together the layers you want. You add in the board support, whichever board you want. You add in the distro for whatever you want it to do, basically. And then you add in software libraries. It's kind of neat. There is an official list of layers at the layer index. If you go look there, you'll see there's 400 or 500 layers you have to choose from. So you can build things together quite neatly. So why can't we do something similar with Android? Okay, so this is... Okay, I misspelled that as well. This is a very early stage, but I kind of want to get feedback either now or later on. So how do we apply layers to Android? In 2 minutes. Essentially, the aosp layer basically is a collection of local manifests, of patches, and also some metadata explaining what the layer does, and also documenting incompatibilities, so which version of Android does it work with, that kind of thing. We divide things up into layers. We can then combine these layers in different ways to add in to make whatever we want. So we could have we can have a board support layer, we can have some HALs, we can have build system changes, and so on. And so one of my wonderful anybody who's seen my lectures will know my diagrams are rubbish, and this is a good example of that. But the basic idea is that essentially when you import the layers that you want, so this would be in a directory somewhere on your system. Here I have 3 layers. I have my BSP, which is the hardware support. I have a generic audio HAL, and I've got a launcher. And I've expanded out what you might see under one of these. So for the audio HAL, we have some changes to the hardware directory, a bunch of patches. We have, of course, some SE policy, because you always need SE policy, a bunch of patches. So you download the layers you want. You then apply some magic command to apply the patch. That patches aosp in a controlled way, and you build a product. So this brings me on to another concept, really, which is a product. So product is a collection of layers. A layer is a collection of metadata. The product then is a single entity, most likely a file, possibly in JSON format or something. So I can then say, go get me the product description from some URL. It will grab the product description. It will download everything, apply the patches, and away we go. So to make this work, we need some tooling. TBD. And just as one final thing then, the idea is that if I were to say I want to get a product, so I want to build, I don't know, an automotive Android for a Raspberry Pi. Somebody somewhere has written the JSON file which explains how to do that. So I just say build Android product, point to that JSON file. It will then read the product file, do a repo init for me to get whichever version of Android it specifies, download the local manifest into the directory, do some checks, do a repo sync in order to bring in all of the local manifest changes, apply the patches, and then you type M and go away for a long holiday while it builds it for you. So that's the basic idea. As I said, this is very much a work in progress. I would very much value feedback from everybody here. Do you have time for like maybe one question? Yeah, I'm in charge. So we have time for one question. So, anybody? I'm totally overwhelmed. Okay, this is a good reason then to do the wrap up now. Thank you very much, and let me know what you think.